Hello and welcome back to another episode of Math with Zone. Today we are going to be doing some simplifying of some radicals. So let's get into it. So in order to simplify a radical, there are a few different ways that you could do it. I recommend using the factor tree method because if you're doing anything beyond a square root, that's the easier method of the two that I know. Okay, so what I mean by factor tree, I mean just divide the 20 up. I recommend dividing by 2 because if you divide by 2 or 3, it makes it a little lined up if you continue to divide by 2 rather than writing 4 and 5 and 2 and 2 and things like that. So here, because it's a square root, you are looking for 2 of a kind. So I circled a 2 of a kind, and I put that number on the outside. Whatever you circled goes on the outside. So I circled a pair of 2s, so I put a 2 on the outside, and whatever's left over that wasn't broken down, the 5 wasn't broken down, remains underneath the square root. Okay? So that's how you deal with regular numbers. And what do you do with variables? So here we're going to start with the square root of 4. The square root of 4 is 2. And if you broke down the 4, you'd also get 2 and 2. So circle the 2. Goes on the outside. Then we have the square root of a bunch of variables. So here's what we're going to do. It's always the square root, which is an invisible little 2 up here. We are looking for 2 of a kind. And when you're dealing with the variables, you have the option of writing out 1, 2, 3 y's, and you'd be like, oh, I have a pair, and then I have 1 left over. But there's an easier way to deal with the y's. How many times does 2 go into 3? Well, it goes into it once, but it has a remainder of 1. How many times would 2 go into 7 for the z to the 7th power? Well, 2 goes into 7 3 times with a remainder of 1. And 2 goes into 6 3 times perfectly. No remainder, so you don't need to write x to the 0 power here. You also don't need to write any of those first powers, but I already wrote them. Okay, so that's how you deal with variables. And if you're still stuck on like number 1, we're going to have some other examples that are similar to that, so don't worry about that yet. Number 3, how do you take a square root of a negative number? Up until this point of your math career, you might not have ever done that. However, it is possible as long as you realize that it is not possible, technically, and you recognize that anytime you have a square root of a negative number, you can pretend and make it positive by just putting I square root of 16. That I stands for the imaginary number I, which is a square root of negative 1. Okay, so anytime you have a square root of a negative, for right now, just write I and then write square root of positive 16. Hopefully, you know that the square root of 16 is 4, but if you don't, you could break it down into 4 and 4 and realize that there's a pair of 4s there. So in this case, we get 4i. Anytime you have a square root of a negative, you just put an I next to it or on the outside of the radical, and you're good to go for right now. What about if you're multiplying two things? If you're multiplying two things, you have the option of simplifying first. So we could simplify the square root of 4 first. You have the other option of multiplying the insides of these things together and outsides if they had outsides. So if there was like a 5 here and a 3 there, you'd multiply the 5 and 3 on the outside. Here, 4 times 2 makes square root of 8. X to the 6 and x to the 6 with you multiplying these two would add your exponents, makes 12. All right? Then you can break down the 8, which ends up being 2 and 4 immediately, which is why you don't have to multiply in the beginning, but I recommend doing it because it's a foolproof way. And then 2 and 2 again. Here you have a pair of 2's and a singular 2 left over, which means that when we break this down, we're going to have a 2 and then a radical 2 left underneath. Okay, what about this x to the 12th? Well, how many times? It's always 2. No matter what number's on the outside, it's always 2 for square roots. How many times can 2 go into 12? That would be 6 times perfectly and none left over. Okay? So multiplying, you just multiply them and treat them like a normal number or a normal thing. But if you're adding doesn't work that way. You cannot add the square root of 8 and the square root of 2. That will not make square root of 10. What you have to do first is break down the 8, which we've already done, 2 and 4. 2 and 2, you got a pair of 2's and 1 left over. Makes this 2 square root of 2 plus 3 square root of 2. As long as the radical part is the same, then you can add, but you're not adding what's underneath, you're adding what's on the outside. So you can think of this as like 2x plus 3x, that makes 5x, but the x in this case is square root of 2. So this is going to be 5 square root of 2. All right, keeping it going. We got the square root of negative 24. What do we do when we have a square root of a negative number? Any negative number, you take out an I, make it a positive 24. Now we have to break down the 24. 24 turns into 2 and 12. 2 and 6, 2 and 3. Okay? So here we have a pair of 2s. 2s are going to be your most popular number. All right? So don't panic that I have a lot of 2s here. 2 is going to go on the outside. But what's already on the outside? A 3. So because there's already a 3 on the outside, and technically these things are multiplied, when I move the 2 out, it's going to make 6i square root of whatever's left over. Whatever's left over in this case would be this 2 and that 3. They didn't pair up. So this 2 and that 3 are going to multiply back to become a 6. All right? Moving on. Now these look harder. They're not harder. You got to be careful that you don't make a mistake, but they're not harder. We have square root of 5 plus 2 times the square root of 2. We're just going to distribute that square root of 2. So we have square root of 2 times square root of 5. That makes square root of 10. We have 2 times the square root of 2. This 2 is not underneath a square root, so when we multiply that, it is going to become 2 square root of 2. Now, we should check to make sure that nothing else can happen. We cannot add square root of 10 and square root of 2 because they're not both a square root of 2. And if we try and break down the 10, we just have a 5 and a 2. That doesn't pair up, so this is our final answer this time. It might not be for number 8. Might not be. Let's see what happens. So here, we have to multiply the square root of 3 times the square root of 6. Square root of 3 times square root of 6 makes square root of 18. And then we have to take the square root of 3 and multiply by 4. So that's going to be 4's on the outside, so 4 times square root of 3. Then we have to do the negative 2 times square root of 6, which makes negative 2 square root of 6. And then we have to do negative 2 times 4, which is negative 8, which is like a double distribution. Other people may call it foiling. Is there anything we can combine yet? No. Square root of 3 and square root of 6 are not the same. Can't combine them. Square root of 18 we might be able to do something with. Let's see what happens if we break down the 18. I'm going to do it off to the side. That way I don't mess up this part. So we got 2 and 9 and 3 and 3. We got a pair of 3s. Finally, a different type of pair. So we have a 3 on the outside and a 2 left underneath. And then we have plus 4 square root of 3 minus 2 square root of 6 minus 8. Does anything combine now? It was so close, but no. 2 and 3 don't combine. 6 doesn't break down. If you break down the 6, all you get is a 2 and a 3. So this ugly mess is all we can do. It was very close to combining, but it didn't happen. Number 9, we have a very similar problem, but this is going to be a unique situation. See how it looks like it's almost the same, but we have a 4 here and a negative 4 there. They're changing the sign in the middle. That's what's called the conjugate. And when you FOIL the conjugate, magical things will happen. We're going to do square root of 5 times square root of 5. You get square root of 25, which is just 5. All right? And then square root of 5 times 4 ends up being positive 4 square root of 5. Then when we do the negative 4, you get negative square root of 5 and negative 16. Well, with the conjugate, with this being one positive 4 and one negative 4, the middle part will cancel. See how we got 4 square root of 5 and negative 4 square root of 5? They cancel. And now we have square root of 25, that's 5. And square root of, not square root of 16, but just negative 16. When we combine those, they're combinable. That's 5 minus 16. That's negative 11. All right, so the conjugate, magical things happen. The radicals disappear, essentially. Okay. All right. In case you didn't know it yet, it is not allowed to have a square root on the bottom of a fraction. If you have a square root on the bottom of a fraction, there's 2 scenarios that you could have. You could have a singular square root, or you could have 2 things on the bottom. See how here we have a square root of 5 and a 4? If you have a singular square root, all you need to do is multiply by whatever is on the bottom. So here we're going to have 4 times square root of 3 on the top of the fraction. That's 4 square root of 3. And square root of 3 times square root of 3 ends up being square root of 9, but the square root of 9 is 3. So this is going to be 4 square root of 3 over 3, because the square root of 9 turns into 3. Anytime you have a radical times itself, it just breaks free of that radical. Okay? So, number 2, nothing really has changed here. We have a 20. You could simplify the 20 in the beginning if you want to. I don't recommend it unless you want to. I recommend just multiplying by the 20 and the 20 and making that 4 square root of 20 over 20, because it's going to be two 20s and they end up breaking free. Now, what's different about this problem is you have a 4 over 20, and the 20 might also simplify. So I'm going to start with simplifying the square root of 20 for the top of the fraction. That's going to be a 2 and a 10 and a 2 and a 5. The 2 will go on the outside, but there's already a 4 there. So 2 times this 4 makes 8 square root of this 5 left over 20. Now, the 8 and the 20 are both on the outside of the fraction. You cannot simplify the square root of 5 over 20, but you can simplify the 8 over 20. If you do that, divide them both by 4, you get 2 square root of 5 over 5. And you cannot simplify the square root of 5 over 5, so this is just 2 square root of 5 over 5. All right. Number 3. Number 3 is a conjugate question, because when you have two things on the bottom, you are going to need to multiply by the bottom, but you're going to want to multiply by changing the sign in the middle. So I'm going to multiply by square root of 5 plus 4 and square root of 5 plus 4, which I coincidentally did here in advance. So you would have to FOIL the bottom of the equation. When you FOIL the bottom of the equation, the middle part will cancel. We've already done this problem, so I'm not going to redo it. If we multiply square root of 5 times square root of 5, you get the 25, and then if you distribute it and keep going, you're going to get everything you got here, and you end up with a negative 11 on the bottom. What about the top of the fraction? The top of the fraction, in this case, you can just distribute, which would make 4 square root of 5 plus 16. That is one version of the answer, where you keep it all as one fraction. You have the option of separating this out into two things, which sometimes has an advantage and sometimes has a disadvantage. The advantage is that maybe one of these things simplifies and the others doesn't. In this case, 4 over 11 doesn't simplify and 16 over 11 doesn't simplify, but you're still allowed to write it as either version of these two answers. Okay? All right. Last but not least, we got some solving practice. The solving practice is going to go a little bit quicker, provided it doesn't simplify. So, in order to solve, as long as it's only an x squared and a number, you're just going to set it equal to the x squared. You're going to get the x squared by itself. So I'm going to subtract 4. If I subtract 4, I get negative 4 equals negative x squared. And then I'm going to divide by negative 1. And we get x squared is equal to 4. Sorry for changing sides there. If you square root when you're solving, only when you're solving, you need to include a plus or minus. And in this case, we got plus or minus the square root of 4, which means x equals plus or minus 2. All right? Moving right along. These are going to be pretty quick, everybody. We're going to divide by 2. 25 does not divide by 2. So we get x squared is equal to 25 over 2. We're going to square root now. Negative 25 over 2. When we square root, when we're solving, we have to add the plus or minus. We have a square root of negative 25. Well, what's the square root of negative 25? Well, that would be I square root of positive 25 over square root of 2. You square at the top and the bottom. So the square root of positive 25 makes this 5i over square root of 2. Oh no, we have a square root on the bottom of the fraction. Oh no, how do we get rid of the square root at the bottom of the fraction? You multiply both things by the square root of 2. And when you do that, you end up with x equals plus or minus 5i times the square root of 2 over 2. All right? That one's probably the weirdest and hardest one out of the solving. Number 3, we're going to subtract 4. We get 9x squared equals negative 4. Divide by 9, you get x squared equals negative 4 over 9. And then when we square root this time, we get x equals plus or minus the square root of negative 4 over 9. Well, 4 and 9 both square root, but it's negative. So when we take out the I, what is the square root of 4? 2. What is the square root of 9? 3. And because it was negative, plus or minus 2 over 3i. Number 4 might look harder, but it's not harder. The squared term is already isolated, so we can square root right as we go. So if you have the parentheses and the squared, you can square root right when you get there. You can get x plus 2 equals plus or minus the square root of 9. I reorganized it. I like the x's on the left side. The square root of 9 is 3. So we're going to get x plus 2 is equal to plus or minus 3. We have to subtract the 2 over, which means negative 2 plus or minus 3 would be our answer. However, this is just a regular 3, right? So if we actually do the math, we get negative 2 plus 3 and negative 2 minus 3. That plus or minus quite literally means add and subtract, which means x equals 1 and negative 5 for our 2 answers. 2 more. Add 42 over. If we add 42, we get negative x minus 3 squared equals 52. And then we divide by a negative because we don't have the squared by itself yet. This is a negative 1 here, so we're going to divide by negative 1. And when we do that, that makes that negative 52. So when we square root, because now we can square root it, now we have x minus 3 equals plus or minus the square root of negative 52. Well, let's see if 52 breaks down. We got to first take out the I, and we get x minus 3 equals plus or minus I square root of positive 52. If we break down the 52, you get a 2 and a 26 and a 2 and a 13. 13 doesn't break down anymore, so this is going to be 2 on the outside, and then the square root of 13. So x minus 3 equals plus or minus 2i square root of 13. And then the last step would be to add the 3. When you add the 3, it just goes in front of the plus or minus. So it's going to be 3 plus or minus 2i square root of 13, everybody. Okay? Last but certainly not least, this time you have an x squared on both sides. So we need to combine them. If we combine them, I'm going to subtract the 4x squared. You get 5x squared. The x squareds don't cancel, equals 0. And if we divide by 5, we get the x squared by itself. You get 0 over 5, which is 0. And if you square root 0, you get 0. So that must mean that x equals plus or minus 0, but you don't need the plus or minus in this case. You could just write 0. Okay, that's going to do it for this one. It was a little bit of a longer one. I apologize for that. Stay positive, and I will see y'all later. Bye.